Hello students, welcome to Study Life. In this video, we are going to discuss the topic of alcohol, phenols and ethers in a quick summary, a recap for which will be important for your forthcoming board examinations. So let's start the topic, that is alcohols, phenols and ethers. To begin with, first the introduction as to what are alcohols, basically the definition. So alcohols are the organic compounds whose molecule contains hydroxyl group as the functional group. So in alcohols, the functional group which is present is hydroxyl group. So carbon, the OH group you can see is attached to carbon atom. So that is what is OH group getting attached to carbon atom is what is called as alcohols in case of open chain compounds. Now if it is an aromatic compound, then you call it as phenols. So in case of alcohols, it has to be aliphatic, open chain compounds, and it is attached to OH as mentioned. And in case of aromatic, it is aromatic attached to OH, then it is called as phenols. Now there are two types of aromatic hydroxy compounds. One you can call it as phenols and the another you can call it as aromatic alcohols. Now what is the difference between the two? When you say phenols, you will have benzene ring attached to OH. But when you say aromatic alcohols, you will have a cyclic ring attached to OH. Say for example, you can have cyclohexanol. That can be an example of your another examples of aromatic alcohols. Now in case of phenols, the OH group is directly attached to the benzene ring. So here as mentioned that OH group is directly attached to the benzene ring. So that's the very basic definition of what is alcohols and what are phenols. Moving on. Now let's talk about the further topic, that is the classification of this particular structure. Now in the classification of alcohols. Now let's first understand the classification of alcohols and phenols. Now alcohols and phenols together, they are classified here as mono, di, tri and polyhydric compounds. Now what are monohydric alcohols? Now when I say alcohols and phenols, we will classify into two parts. One is alcohols, another is phenols. So here the first one is monohydric alcohol. Here you can see only one OH group is attached. So if only one OH group is attached, then it is called as monohydric alcohols. Now here if you can see in the second structure, there are two OH groups attached. So if two OH groups are attached, then it is called as dihydric alcohols. And in the third one, it is three OH group getting attached, which makes it to be called as trihydric alcohols. So you have got monohydric alcohols, dihydric alcohols and trihydric alcohols. On similar grounds, even the phenols have the classification benzene ring attached with OH. Now here this is only one OH, so it is called as monohydric phenols. It's not alcohol, it's a phenol. So monohydric phenols. Same way there are two OH groups here, so it becomes dihydric phenol. And if there are three, then it is called as, here there are three OH groups, so it is called as trihydric phenols. So now this classification continues further. As we can see, we'll go ahead with the next classification. Now this classification of monohydric alcohols, they are further classified on the basis of type of hybridization. So on the basis of type of hybridization, the first classification is alcohols which contains carbon which is sp3 hybridized. Now, what is sp3 hybridized? Means it should have a single covalent bond. So if carbon is sp3 hybridized, it has single covalent bond and attached to OH. In these alcohols, the OH group that is attached will be sp3 hybridized as mentioned. They can be further classified as primary, secondary, tertiary alcohols. So your primary alcohols, secondary alcohols and tertiary alcohols, they all are coming under the category of carbon which is sp3 hybridized and it is further attached to OH group. This is the further classification of monohydric alcohols. Now what is it? Primary, secondary and tertiary, that also is very important to understand. Now here in this case, now this is the OH group. As you can see here, this is the OH group. Now this OH group is attached to the carbon which is attached to only one carbon atom, right? So it's attached to only one carbon, that is only one R group. So if OH is attached to a carbon which is attached to only one carbon, then it is called as primary alcohol. Similarly, if I'm talking about secondary alcohol, then what's the difference? So OH is attached to a carbon, which is in turn attached to two other carbon atoms. You can see 2 are over there, right? So OH is attached to a carbon, which is in turn attached to two another carbon atoms. Then it becomes what is called as secondary alcohol. So you have got primary alcohols, you have got secondary alcohol. Now the next one is tertiary alcohols. Now this is OH here, and this is attached to a carbon, which is in turn attached to, you can see here 1, this is 2, and this is 3 here. This is 3 another carbon atom. So that's how OH is attached to a carbon, which is in turn attached to 3 another carbon atoms. So this is primary, secondary, and tertiary. Moving on to the next type, that is called as allylic alcohol and benzylic alcohol. Now basically, what is allyl group and what is benzyl group? How do you understand it? So just put up a structure on the screen. You can just see CH2 double bond CH, single bond CH2, and a bond like this. Now this structure that you can see, CH2 double bond, double bond CH, single bond CH, single bond CH2, that together is what is called as allyl group. So that is called as allyl group. So that is allylic alcohol. Now here the doubt that you have is double bond is seen, and I told it is carbon is sp3 hybridized. You need not get confused with it, because the reason for it is, now if I am attaching my OH here, so OH is attached to a carbon which is attached to the next carbon by how many bonds? It is by a single bond. You can see this double bond is somewhere else. So this is what you should know when I say allyl group. So OH is attached to a carbon which is attached to the next carbon by a single bond. So again, it is from the category of carbon which is sp3 hybridized and attached to OH group. Moving on to the next one, that is benzylic alcohols. This also comes under the same category. Now, in case of benzylic alcohols, when we are saying how does the structure looks like, it would be a benzene ring, something like this. It's a benzene ring, and in this benzene ring with alternate single and double bonds, you have got CH2OH. Now what I'm trying to put up the explanation is that if it is here OH, OH is attached to the carbon which is attached to next carbon by a single bond. If you see this OH here attached to the carbon here, this is attached to the next carbon by a single bond in between. This single bond I am referring to. This is the benzene ring, that is fine, but the basic part of my discussion is OH getting attached to the carbon which is attached to the next carbon by a single bond. This single bond is very important. This is again what is making it to be called as carbon which is sp3 hybridized and attached to OH. So together, carbon which is sp3 hybridized and attached to OH together are 5. Which are they? Primary alcohols, secondary alcohols, tertiary alcohols, and just now we did, that is, this is the primary, secondary, tertiary, the structures in the boxes, and just now what we discussed is allylic alcohol and benzylic alcohol. So this completes together what is the basic classification of alcohols. That is monohydric alcohols classified as carbon which is sp3 hybridized and attached to OH group. Now let's go ahead for the next classification, wherein I'll be talking about carbon which is sp2 hybridized and it is attached to OH. Yeah, we can remove this. All right. Now the next one is carbon which is sp2 hybridized and which is attached to OH group. Now in this case, sp2 hybridized, when I say, again sp2 hybridized is wherein you have a double bond. sp3 hybridized means single bond, sp2 hybridized means double bond, and the best example is of vinyl alcohol. Now here you have the structure of vinyl alcohol. You can see this is the structure of vinyl alcohol. In this structure of vinyl alcohol, what you have basically is, this is OH here. Now this OH is attached to a carbon which is attached to the next carbon by a double bond here. This is what I'm trying to make you explain. So here OH is attached to a carbon which is attached to the next carbon by a double bond, isn't it? And that is what makes it to be called as carbon which is sp2 hybridized. This is carbon which is sp2 hybridized and attached to OH. So this is together what is the classification of alcohols and phenols. Now we move to the next one, that is the classification of ethers. Now, in the classification of ethers, yes, ethers has the functional group of O bonded on two sides with two another bonds. If both the sides, the groups which are attached are the same, then you will call it as symmetrical ether. So then it is called as symmetrical ether. So there are two types again. One is called as symmetrical ether and the another is called as unsymmetrical ether. So two types, symmetrical ether or unsymmetrical ether. Now here both the R groups are same, or both the AR groups, that is aromatic groups, are same. So if both R groups, that is alkyl groups, or aromatic group are same, then what are they called as? Then they are called as symmetrical ethers, or you can also term it as simple ethers. Moving on to the next one, wherein you have got R and you have R dash. So that R and R dash is what is called as unsymmetrical ethers. So where you have got two different alkyl groups, they are unsymmetrical ethers. So symmetrical ethers are also called as, yes, simple ethers, and unsymmetrical ethers are also called as mixed ethers. So you should remember both the names in the examinations. Either of the way questions can be framed. So either you can have simple ethers or you can have mixed ethers. Moving on to the next part, that is the nomenclature part now. Now in the nomenclature part, basically when you are giving the names, we have two systems of nomenclature. One is called as the common name and the another is called as the IUPAC names. According to the common system, now basically in the common system, what you have, we are using the word alkyl alcohol. The common names, or which is also termed as, that is also called as trivial names, they are obtained by adding the word alcohol to the alkyl group. So you have the alkyl group, and to that alkyl group you are using the word alcohol. So normally you have the prefix like say iso, secondary or tertiary. Just now we said what is secondary, what is tertiary. If it is attached to 3 carbon, it is tertiary. If it is attached to 2 carbon, it is secondary. That is what we have already mentioned. Now comes something very new topic for the new textbook that has been upgraded. Now that is called as the carbonyl system. Now basically in this carbonyl system, what basically are we talking about is, now this compound here is CH3 CH2OH. Now this is carbonyl system. Now what is that carbonyl? Now this group here is called as the carbonyl group. CH2OH group is called as the carbonyl group, or COH basically, that is the carbonyl group. To this carbonyl group, what has been added? Let's try to cross check it here in this way. I'll just change the ink. What has been added? CH3 has been added. So now CH3 has been added, so it becomes what? It becomes methyl carbonyl. So carbonyl changes to methyl carbonyl. This is what is the changes because of the suffix prefix that we are using. So in this system, alcohols are considered as derivatives of methyl alcohol, which is called as carbonyl. So basically that methyl alcohol is carbonyl, but when you are replacing it with more hydrogen, so then it becomes methyl carbonyl, or it can be ethyl carbonyl, so on and so forth. Such other compounds are possible. Now we'll move to the next part of this topic, wherein we are going to talk about the IUPAC nomenclature. In the IUPAC nomenclature, the E of alkane, as we already know this basic rule, that E of alkane is replaced by OL. So in the IUPAC nomenclature system, E of alkane is generally replaced by OL. This is only for monohydric alcohol. That is something very, very important. When you are talking about monohydric alcohol, for monohydric alcohol, E of alkane is replaced by OL. But if you are having the same alcoholic group repeating, then you don't replace that E. That E is retained. How it is retained? It's one of the example is shown over here as ethane 1,2 diol. So how it is done, that we will see in the example that we are coming up here with in this chart. So this is the nomenclature system of alcohols. Now in the nomenclature system of alcohols, as you can see on the screen, this is CH3OH. This is CH3 is which group? Methyl. Yes, so it is methyl group. So this is called as methyl alcohol. The next one, what we have is now, the next one is now for this methyl alcohol, how many carbon atoms? Yes, it has got only one carbon atom. So if it has only one carbon atom, what is the parent alkane? The parent alkane is methane, and E of alkane is replaced by OL. So it becomes methanol. The next one, CH3CH2OH. Now in this case of CH3CH2OH, now here you have OH attached to 2 carbon atoms, and for that the alkyl group is ethyl group. So it is called as ethyl alcohol. So OH is the suffix, so alcohol will be the suffix, and alkyl group is, yes, ethyl. So it is ethyl alcohol. Same way, now the IUPAC nomenclature, again there are 2 carbon atoms. For 2 carbon atoms, the parent alkane is ethane, so it is ethanol, wherein E of alkane is replaced by OL. The third one, CH3CH2CH2OH. Now in this case, you will start numbering from right to left. This is your, say, first carbon, second carbon, and this is your third carbon. Alright, so this is your how you have the carbon atoms. Alright, so this is the first carbon, this will be your, say, second carbon here, and the third carbon. So now when there are 3 carbon atoms, in the common name it is called as N-propyl alcohol. For common name it is N-propyl alcohol. For the IUPAC name it is called as propan-1-ol, because at the first position you have got OH attached. So it is termed as propan-1-ol. The next one coming up, now this is the next structure here. This is again first carbon, second, third, and this is fourth carbon. Yeah, a total of 4 carbon atoms. For 4 carbon atoms it is butane. So it is butane, and at the second position you have the OH. So it is butan-2-ol. Now here it is written sec-butyl alcohol. Now what is that sec-butyl, or how do you come to know it is sec-butyl? So again try to cross check. This is your OH here. This is attached to a carbon here. This is the carbon. And this carbon is attached to how many carbon atoms? Yes, 2 carbon atoms. So OH is attached to a carbon which is attached to 2 other carbon atoms. And that is what makes it to be called as sec. So it is called as sec, that is secondary butyl alcohol. So total of 4 carbon, so it is butyl. So it is now sec-butyl alcohol. The next one, now here OH is attached to a carbon which is attached to how many carbon atoms? Yes, it is attached to 3 carbon atoms, 1, 2 and 3. It is attached to here 3 carbon. Now this is called as tertiary carbon. That carbon becomes a tertiary carbon. So it is now called as tertiary carbon. So it is here tertiary butyl alcohol. Otherwise you will not understand the name. It is tert butyl alcohol. Now coming on to the IUPAC name of this compound. Now this is top to bottom. I will be selecting it. So first carbon, second carbon, third carbon. On my second carbon, what do I get? On my second carbon, I get OH and I have CH3. So it is 2-methyl. Second carbon is 2-methyl. Yes, this is 2-methyl. And on the second carbon, I have OH also. So it is propan-2-ol. So it is now 2-methyl propan-2-ol, because on the second position, I have OH also. So top to bottom, 1, 2, 3. Second position CH3, 2-methyl propan-2-ol. So this is 2-methyl propan-2-ol. Now coming on to the next structure. Now this is slightly changed. It's not a monohydric alcohol. There are 2 OH groups. Now if there are 2 OH groups, in case of common name, such system is called as glycol system. For common names, it is termed as glycol system. And in that glycol system, now when it is 2 carbon, it is termed as ethylene glycol. So the name of the compound is ethylene glycol. The next one, now here it is an IUPAC name, first carbon, second carbon. So in all there are 2 carbon atoms. Parent alkane is ethane. Now very important thing, E will not be replaced. That is something very important. E is not replaced. So it is ethane 1,2 diol. So it is ethane 1,2 diol. So first position, second position. So 1,2 diol. So it is ethane 1,2 diol. Alright, the next one, the next structure on your screen, that is CH2OH, CHOH, CH2OH. So there are 3 carbon atoms with 3 OH groups. That 3 OH group system is called as glycerol. That is basically termed as glycerol, and therefore the name of the compound propylene glycerol. And here it is first, second, third. So in all propane, and for that propane together, first carbon, second carbon, third carbon. So it is propane 1, 2, 3 triol. Tri, this is 3. So it is 1, 2, 3 triol. The next one, CH3, CH double bond CH, CH2OH. Now in this case the common name is crotonyl alcohol. It's obtained compound from crotonyl alcohol. Now the IUPAC name, how is it mentioned? Now that we will see. This is the first carbon, second carbon, this is the third one, and this is the fourth one. So in all 4 carbon atoms, so it is but. Double bond is between second and third, so it is but 2 in, and first position is OH. So but 2 in 1 all. So the name of the compound becomes but 2 in 1 all. This is the compound but 2 in 1 all. This completes your nomenclature part of alcohols. Now coming on to the nomenclature part of phenols. In the nomenclature part of phenols, now how will you give the names for phenols basically? Now the first compound itself, benzene ring with OH. Now if you see this benzene ring attached to OH here. Now this benzene ring which is attached to OH, you will realize one thing very common, that this is phenols here also. This can be called as phenols here also. Yes. So there are some compounds wherein you will have the same common names and the same IUPAC names also. They are likely possible. So it is phenols and phenols. One another name for IUPAC name, it could also be called as benzenol. So benzene, basically it is benzene, and that E of alkene is, or benzene, is replaced by OL. So it becomes benzenol. So either you call it as benzenol or you call it as phenols. The next compound, benzene ring with OH and CH3. Now this is 1 and 2 position. So that is called as ortho position. And that is why the compound is orthocresol. This is called as orthocresol. Now same way, first position and second position, so it is 2-methyl, and then benzene ring with OH is called as phenols. So it becomes 2-methyl phenol. Same way, now this is again here the next one. This is first position and this is fourth position. So go like this, 1, 2, 3, 4, or it can be 1, 2, 3, 4. Either of the way you go, this is the fourth position, and therefore this compound will be para position. So para, nitro, and then it is phenols. So that how the breakdown is, para, nitro, and then phenol. Or this can also be mentioned as 4-nitrophenols. So either it is para-nitrophenols or it is 4-nitrophenols. Now here it is benzene ring with OH, OH. Again, this is dihydric phenols. See, when you see the structure, try to recognize it. Try to classify it. So this is benzene ring with OH and OH, dihydric phenols. And the name of the compound is, it is called as catechol. This is termed as catechol. Also called as in IUPAC name as benzene 1,2 diol. So first position and second position. So benzene 1,2 diol. The next one is benzene ring with, this is first position, this is third position. In common name, it is called as resorcinol, and in the IUPAC name, it is called as benzene 1,3 diol. This compound is benzene 1,3 diol. This is resorcinol, also termed as benzene 1,3 diol. The next one, again, this is the first position and this is the fourth position. Now this is hydroquinone, or it is called as quinol position, and here the compound is benzene 1,4 diol. So first and fourth position. So benzene 1,4 diol. Same way, this is now first position, third and fifth. So this common name is fluoroglucinol, and the IUPAC is benzene 1,3,5 triol. Lastly, this is now benzene ring with OH, OH, and OH. This compound is termed as pyrogalol, and in the IUPAC name, this is your first carbon, second carbon, and third carbon. Now numbering is also important. Very carefully, you should select it in such a way that you get the lowest locant rule. What is that lowest locant rule? Is when you add this together, you should get the least number. So 1, 2 and 3. 1 plus 2 is 3. 3 plus 3 is 6. Now here, if I take it in this way, 1, 2, 3, 4, 5, 6. This will be 5 and this will be 6. It will give you a larger number, which is not possible. Because what we want is, as per the IUPAC rules, we want a lowest set of low controls. So it is benzene 1, 2, 3 triol. So this completes your nomenclature for phenols. So you have nomenclature for alcohols, nomenclature for phenols. Let's move to the next part, that is the nomenclature for ethers. So alcohols, phenols is done. Now the nomenclature for ethers. Now in the nomenclature for ethers, as far as the common names are concerned, in case of common names, you generally write it as alkyl ether. And if it is the same alkyl group, then you will go for the prefix of, yes, you will go for the prefix of di. And if it is different alkyl groups, then what you have to do? Then you have to follow the alphabetical order rule. So let's cross check this few things over here. In the first one, it is CH3OCH3. Now if it is CH3OCH3, now the two groups are same, CH3, CH3. So it becomes dimethyl ether. So it is the formation of dimethyl ether. Or you can also call this as, now this is the common name as dimethyl ether. Coming on to the IUPAC names. In case of IUPAC names, there are some changes that we will just talk. Let us first concentrate on common names and then I'll come back here for IUPAC. For the second one, CH3OCH2CH3. Now here this is which group? This is ethyl and this is methyl. So E and then M. So follow the alphabetical order. I have mentioned it. That is ethyl, methyl, ether. So the name of the compound becomes ethyl methyl ether. The next one is same way, CH3OCH2CH2CH3. Now in this case it is methyl and these are 3 carbon atoms, propyl. So again methyl is M, propyl is P. So it is methyl N-propyl ether. So this is methyl and then N-propyl ether. The next one, C6H5OCH3, methyl phenyl ether. So this is methyl group and C6H5 is called as phenyl group. So methyl is M, phenyl is P. So methyl first and then phenyl. So the name of the compound is methyl phenyl ether. The next one is benzene ring with O, CH2, CH2, CH2. Now this is not CH2, this is a misprint, this has to be CH3 here. Alright, so this is a misprint, this has to be CH3 here. So now this is phenyl N-propyl ether. So phenyl is PH, this is phenyl group here. And there are 3 carbon atoms, so this is propyl group. This is phenyl here, this is propyl here. So this is phenyl N-propyl ether. Alright, and already you know this, if the compound is highly branched, then every time you need not have the common names. Alright, so it's not necessary that every time you will have a common name. Now here the compound is highly branched, so here you don't have the common names, not needed. Now coming back to the IUPAC nomenclature system. In the IUPAC nomenclature system, what exactly are we doing? For the IUPAC nomenclature system, for ethers, it is called as alkoxyalkane. Yeah, I'll just annotate it here for you. Alkoxyalkane. When we are using this word alkoxyalkane, this alkoxy that I am talking about, this alkoxy group that we have is basically the one which is having lower alkyl group. So this is lower alkyl group, and this one alkane is the one which is having higher alkyl group. Now what is that lower and what is that higher? Let us understand this clearly. What do you mean by that lower and higher? That I'll just come to an example to talk to you. This example is clear. The second one, CH3OCH2CH3. Now in this case you have got O in the center. Now this is CH2CH3 is 2 carbon atoms. Here this is 1 carbon atom. Which is the lower one? The lower one is CH3. So this will combine with O and that will give you methoxy, right? And then this is the larger alkyl group which is alkane. Already I have mentioned this here. that lower alkyl group is alkoxy and higher one is alkane. So in that case, you will have the higher one as alkanes. So here lower one is methoxy and the higher one is alkane, that is ethane. So it becomes methoxyethane. So this is the formation of alkanes, methoxyethane. The next one, now in the first one it is CH3OCH3. Now in the first one both the groups are same. So you cannot call it to be a larger or smaller one. So any one can combine with O and that gives you methoxy here in the first one, and leaving that is one carbon. So one carbon, what is left out here is nothing but what is methane. So it becomes methoxymethane. So the name of the compound is methoxymethane. Same way now, moving on to the next one, CH3OCH2CH2CH3. Now this is alkane with 3 carbon. This is the alkane, longest chain, alkane with 3 carbon. At the first position here itself, you have got CH3O. So this is called as 1-methoxy, CH3O. This is 1-methoxy and these are 3 carbon atoms, so it is propane. So the name of the compound becomes 1-methoxypropane. Alright, the next one is C6H5OCH3. This is here methoxybenzene. This structure can also be put up for your understanding in this manner. Now this is C6H5 and then this is here O and CH3. Alright, so this is how you have the structure, benzene ring with OCH3, and that is what is called as methoxybenzene. So this is CH3O. This becomes your methoxy and this is benzene. So this becomes methoxybenzene. Alright, the next one you have, again this is 1, 2, 3. This is 1-propoxy. 3 carbon atoms. So for 3 carbon atoms it is prop. So it is 1, 2, 3 propoxy. Oxygen is there. So propoxy, and then what you have? A benzene ring. So it is propoxybenzene attached here. The last one, this is now a bit important. This is here, this is your benzene ring, CH3, CH3 and OCH3. Now 2-methoxy. This is the first carbon, second carbon. On the second carbon you have this methoxy. So it is here 2-methoxy. This is here 2-methoxy and then followed by 1, 1 dimethyl. On the first position there are 2 methyl groups. So if there are 2 methyl groups here, you can see. So they are 2-methoxy, 1, 1 dimethyl, and this is 4 carbon atoms ring. So cyclobutane. So it is cyclobutane. So this completes the nomenclature together of alcohols, phenols and ethers. So alcohols, E replaced by OL. For phenols we have discussed the different types, monohydric and dihydric phenols. And now for ethers, as I mentioned, alkoxy alkane, where alkoxy is the lower alkyl group and alkane is the higher alkyl group. Moving on, we'll start now with the further topic, that is methods of preparation. So the next one is methods of preparation of alcohols and phenols. Alright, now the first method of preparation, now this is a topic wherein you will realize most of the time something like this written in your textbook, that it is completed somewhere else. Because now this topic are in correlation with different chapters. It can be in different chapters of your 12th or it can be in couple of chapters of your 11th also. You have to have a follow up and a proper thorough study of organic reactions. So let's start. The first one is from alkyl halides. Now by hydrolysis of alkyl halides, now this already is done in the topic of haloalkanes, but just let me give you the reaction exactly what happens. It is Rx plus KOH aqueous. It is Rx plus KOH aqueous, and that gives you the formation of ROH and KX. This is what is the basic reaction. So alkyl halide is Rx, hydrolysis with aqueous alkali. Now what alkali am I using here? KOH, potassium hydroxide. Other than potassium hydroxide, it can be sodium hydroxide, it can be silver hydroxide, and it gives you the formation of what is called as alcohols. So this gives you the method of preparation of alcohols. The second reaction is again by acid catalyzed hydration of alkenes, wherein it reacts with sulfuric acid. Now here also they have mentioned that it is completed in your class 11th. So most of the times, now see, when your textbooks are framed, this is what happens. 11th and 12th, it's a combined study. It's not that you forget the concepts of 11th and you come to 12th. It's a building up study. So now this is already completed in 11th, already mentioned. Anyways, we will have a quick revision of that also. So by acid catalyzed hydration of alkenes, what exactly happens here is CH2 double bond CH2, that is your alkene, will combine with HOSO3H, that is concentrated under cold condition, and this will give you, now here this one H gets added up here, so this is here CH3, the double bond breaks, and this will give you the formation of, this is here single bond, now this is CH2 and this is here OSO3H. So this is how the reaction takes place. CH2 double bond CH2 plus HOSO3H in cold condition, and that gives you this one H getting added up here. So this gives you CS3, the double bond breaks, single bond CH2OSO3H, and this compound is what is called as ethyl hydrogen sulfate. See the way it has been explained. That will give you the trick to remember in your exams. This is ethyl, CS3CH2 is ethyl, this is here hydrogen, and this is here sulfate. So it is ethyl hydrogen sulfate. Now the next reaction, this was your second reaction. Now the third one is hydroboration reaction. Now in case of hydroboration reaction, which is oxidation of alkenes, now hydroboration needs a reactant called as diborane. So it is diborane, that is B2H6, which will undergo addition reaction. When this undergoes addition reaction, it gives you the formation of trialkyl borane. So first step, that is alkene, will react with this diborane and it will give you the formation of trialkyl borane. So this trialkyl borane is basically the first step. And in the second step, now here this is the second step, this is the second step. In the second step, the further reaction with peroxide takes place. So there are two steps. In the first step, what happens is the reaction that is occurred by, here it is. The first reaction is hydroboration. First one gives you the formation of trialkyl borane, and second one, it gives you the formation of alcohols. All right. Now here some of the mechanisms in between. Now this is few parts are deleted, undeleted. We'll go with the general discussion for all the parts for this academic year because of the pandemic situations. But anyways, we are going to revise the whole thing, which will also be helpful for your competitive exams. So here the mechanism of acid catalyzed reaction. Just now the reaction that I was showing you on the screen was this reaction. This reaction. This is the acid catalyzed reaction. And for this acid catalyzed reaction, the mechanism of the reaction. Now what exactly is the mechanism of the reaction? The first step, you have a carbon-carbon double bond. This carbon-carbon double bond reacts with acid hydrolysis. So it is the hydronium ion. This structure that you can see is H3O+. What is that H3O+? Yes, it is hydronium ion. That hydronium ion will react with this to give you the first intermediate. That first intermediate gives you carbon with a positive charge. That is the formation of carbocation. So here when this reaction takes place, water molecule is eliminated, H2O is eliminated, and this H gets attached here, and you will get carbon with a plus charge. So when you get this carbon with a plus charge on the screen, this is one. This carbon is called as carbocation. So first step is formation of carbocation as an intermediate. Second step is nucleophilic attack of water. Now this water which has been formed here, that water will now react with this carbocation and it will give you the next compound here. And from this next compound, it is the deprotonation, that is one H has to be removed. and if this one H is removed, then you get your formation of alcohols. That's how the alcohol OH formation takes place. This is a simple mechanism to understand the formation of carbocation as the first step, nucleophilic attack of water as the second step, and deprotonation reaction as the third step. This is how you will have the step 1, step 2 and step 3 of the mechanism. The fourth reaction on your screen, that is by reduction of carbonyl compounds. Now basically, what are carbonyl compounds, or how do you understand the word carbonyl compounds? When you have got C double bond O and 2 bonds like this. This is the structure, or this is the representation of carbonyl group. So this group is what is called as carbonyl group. This is the carbonyl group. This C double bond O is carbonyl. Now in that, the first reaction is by reduction of aldehydes and ketones. Now first one is RCHO, that is aldehydes, which will react with H2, that is hydrogen molecular, in presence of nickel, platinum and palladium to give you primary alcohols. So again, a point to remember, a point to recollect, that is, primary alcohols on oxidation gives aldehydes, and the opposite, that is aldehydes, on reduction gives primary alcohols. What you have is primary alcohols on oxidation gives aldehydes, and aldehydes on reduction gives you primary alcohol. This is how the reaction continues. Same if it is secondary alcohols, it will be the opposite. The small change will be there in case of secondary alcohols. If it is secondary alcohols here, so if you have ketones to start with, ketones will react with H2 to give you secondary alcohols. Means in simple words, you can say that secondary alcohols on oxidation gives ketones, and that ketones on reduction gives you secondary alcohols. So you get both the reactions. Primary alcohols on oxidation gives aldehydes, secondary alcohols on oxidation gives ketones. The next reaction is reduction of carboxylic acid. Now in the reduction of carboxylic acids require strong reducing agent. So just now what we were adding was H2, molecular hydrogen, in presence of nickel, platinum or palladium. They are called as mild reducing agents. So here this is an example of a strong reducing agent. So here they have a strong reducing agent and they will give you the formation of primary alcohols. So here RC double bond O single bond OH, that is carboxylic acids, will give you the formation of alcohols. So from carboxylic acids, what you get is alcohols in presence of LiAlH4, lithium, aluminium hydride and acid hydrolysis. So this will give you the formation of corresponding alcohols. Now, is this used regularly? Can it be used? There's a statement coming up. However, LiAlH4 is expensive reagent, very costlier one. So it's an expensive reagent. Therefore, commercial method of preparation is not possible. It cannot be done for commercial methods. It can be used in the laboratories. So commercially, acids are first transformed into esters, which on catalytic hydrogenation gives alcohols. So you have got a different way to work out for the cost economy. For that, what you are doing is, first step, you are converting it into ester, and after ester undergoes hydrogenation, then you give the primary alcohols. Now again, something important for your competitive exams in between. What is the advantage of LiAlH4? So the advantage of LiAlH4 is that it does not reduce the isolated olefinic bond, that is carbon-carbon double bond. So if you have a carbon-carbon double bond and you have a carbon double bond oxygen, that time the use of LiAlH4 is only on C double bond O and not on C double bond C. That's something very important. So the statement very clearly mentions the advantage of LiAlH4 over this is that it does not reduce the isolated olefinic bond. What is olefinic bond? Carbon-carbon double bond. And hence it can reduce unsaturated aldehydes and ketones to unsaturated alcohols. That unsaturated will remain as it is because there is no reaction for carbon-carbon double bonds. That's a very important point to note. Alright, so this is all about the reaction. The next one is by the addition of Grignard's reagent. Now what is that Grignard's reagent basically? Yes, Grignard's reagent is called as alkyl magnesium halide. That is basically what is Grignard's reagent. So the Grignard's reagent will undergo reaction with carbonyl group, that is either it can be aldehyde, it can be ketone, and when it gives you the reaction, the first step you will get the adduct, that is addition product, and second step that will give you the formation of alcohols. Now the most important thing to understand over here is what different types of alcohols are formed. You will get the formation of primary alcohols, secondary alcohols and tertiary alcohols. If you start with the reaction with say formaldehyde, then you will get primary alcohols. This is formaldehyde, gives you primary alcohols. If you start with aldehyde other than formaldehyde, then you will get secondary alcohols, and if you take in ketones, then you will get the formation of tertiary alcohols. So students, we have completed in this video till the methods of preparation of alcohols. In our upcoming video, we'll be further continuing with the brief revision of the topic of preparation of phenols and ethers. So stay tuned with Study Live. Thank you. See you there.